Hello everyone, welcome to my YouTube channel CodeSpace. Hope you are doing great. Today we are going to learn data structure and algorithms. We are going to understand in this video the basics of data structure and algorithms. What is data structure and algorithms? So let's get started. So a data structure is a way of organizing and storing data in a computer so that it can be accessed and modified efficiently. Data structures provide a means to manage and manipulate data, making it easier to perform various operations on that data. In a computer, we have a limited amount of resources like CPU, memory, or storage. So, utilizing all these resources efficiently, we have to manage and organize them. Through data structures, we can organize and manage these data efficiently. So, that's why data structure is very important and basic fundamentals for computers and programming. So, let's jump into some basic examples for data structure. Here are some examples of common data structures that we utilize in our daily or in routine programmings. So first one is arrays. Arrays is an ordered collection of elements. It is a contiguous memory allocation where our specific size of list or arrays is stored in memory. So it is used for fast access of elements. Insertion deletion is very slow in this case. So array is one of the data structures. Another one is linked list. It is also an ordered collection of elements, but here the memory is not contiguous. It can have data and reference to the next element, which we called as node. So one node can be associated at one memory location, but another node can be at different location, but not necessarily to be at the contiguous to the first one. So that's why linked list is very important when we have to utilize our limited memory where specific locations or contiguous memory is not available. Okay. Next is stack. Stack is a linear data structure that follows last in first out, that is insertion and removal at the same point at the end point. Okay, so let's move to some more examples. Queues. Queues is also a data structure that follows the first in first out principle. The elements or the nodes are inserted or removed at different, inserted from the rear end and removed from the front, like in a normal queue where we go to some shopping or some ticket counters. So similarly first come first serve basis. So similar way the queues perform. Next is trees. Trees is a hierarchical data structure. Basically it works like the trees we called. So one node is the basic unit of this tree and it is linked through multiple edges or branches which help us to construct the complete tree or traverse the tree. There are many kind of trees like binary search tree, balance tree and many others. Next is graphs. Graph is also a collection of nodes connected by edges. In trees, we perform some sort of pattern, but in graphs, we can have one node connected to multiple edges. So it is a different kind of a structure, but it is also a collection of nodes. Last one we are going to talk about is hash tables. Hash table is a data structure which uses hash functions as keys to map values. So basically it is used for faster access of the values based on the keys because it works as an indexing. So we will talk about next later. So basically in hash table we know the address and go to that straightforward. An algorithm is a step-by-step procedure, a set of rules or the instructions to perform a specific task to solve a particular problem. Algorithms are essential for performing operations on data structures efficiently. This helps in achieving or getting the desired outcome by efficient way and utilizing minimum resources. So basically it's a kind of steps or instructions which we follows to solve a particular problem. Okay, let's see some of the examples. The common algorithm examples are searching algorithms. For example, we have a linear search or binary search where a data is stored in a form of maybe in linked list or arrays, and that is a data structure. Now we have to search a particular element in that linked list or arrays. So it can be performed by various algorithms of searching like linear search or binary search. Okay. Another is sorting algorithms. We have to arrange the data elements in a specific order, and there are many sorting algorithms like bubble sort, quick sort and mass sort. Graph algorithms. Graph algorithms are for traversing and manipulating graphs. There are multiple uh, algorithms like depth first search, breadth first search for these purpose. Dynamic programming, a technique to solve complex problem by breaking into simpler or small subproblems. Fibonacci sequence calculation. Some more examples are here like greedy algorithm that make locally optimal choices at each step with the hope of getting a global optimum, a Huffman coding. Okay. Another is backtracking algorithms used for finding solutions to problems through the incremental build-up like puzzle solving, like NQ's problem. Divide and conquer, a technique that divides problem into smaller subproblems and solve subproblems independently and combine the results together to solve the original problem. Okay, one of the example is merge sort. Recursive algorithm, where the algorithm solves a problem by solving smaller instances of the same problem. Like you have a bigger problem, you come to the small instance of that problem and solve it, and then recursively joins that back to continuously solve the complete problem. That is the original problem. One of the solution is factorial calculations. So what we learned today are the definitions of data structure and algorithms, and few more examples of data structure and algorithms. So hopefully you are able to understand some basic understanding of what is a data structure and why we have to use it in algorithms and what are algorithms.